Hello everybody and welcome to this XBlue broadcast about a DriX mission that we want to show you. My name's David Cunningham and I'm here with Olivier Moisin, who's our DriX operations manager.
Hello David.
And we are in XBlue headquarters just west of Paris in France, in the DriX control room here. We'll go into a little bit more details about that in a second. But just a bit of background of what we're going to do and why we're doing it. So we would have hoped to have met many of you at Oceanology International in London this year. We haven't been able to do that. So one of our goals at that event was to show DriX in operation. And because we haven't been able to do that, we've made this small movie. What we're going to do is show you the operation with two DriX, which we're going to control in the Mediterranean, so in the south of France, doing two separate missions with two different payloads, two different survey softwares operational in each of those, all from the control center here in Paris. And we want to show some features of the software and the general kind of DriX control environment. Maybe Olivier, you could start with just by giving us a quick overview of what we've got here in this control center and how it fits together.
This nice setup. On the big screen just behind us, we've got the DriX HMI, which will allow us to actually see all of the parameters from both DriX and actually conduct and supervise the operations. We've got access to all power supply and all telemetry data inside of each of the DriX. And we also have the, like you said, the survey navigation softwares. We're using two different kinds of navigation software for this demo. And these four screens are actually repeated on this monitor here to give the operator, a nice look of all of the data and being able to do all of this quality control as the operation are going.
Okay, so quite a simple setup. So we've got the survey operation, which is really what this mission is all about. We've got the vessel control for each of the DriX, and then this the general overview of the entire mission. Okay, great. That's a good introduction, Olivier. So now let's get to work. Okay, so Olivier, we've got the setup. We've got our two DriX on station. We can see on the big picture here the big overview, the two DriX. So let's get to work.
Okay.
Where are we going to start?
I suggest we start with Marseille. What don't you think?
Okay.
Okay. So what I'm going to do first is put the DriX that is in La Ciotat in standby. Mm-hmm. We don't want it to drift around. So from the main DriX HMI, I'm just going to click on DriX number 3, which is in La Ciotat. It's going to zoom in onto it. So here on the screen we are in La Ciotat. And I'm just going to use a mode that we call the hovering. So right-clicking, hovering modes, then it draws a circle, and DriX will have to stay within the circle. I just define the radius of the circle. For example, let's put it to 100 meters. Okay, I'm going to put to 8 knots. And then I have the possibility to launch it on its mission using the play button. Mm-hmm. Just starts. And then you see a green route that is designed. That's the computation of the route to go to its mission. And you see that it's turning and going into that circle. In the conning data here you see the speed, you see the heading, and you see the engine RPM. As soon as it will reach the middle of the circle, it will stop. And if the waves or the wind are blowing and is going out of this circle, it will just directly maneuver back in, exactly. Okay, so this one is in standby. Then I'll click on DriX number 6, which is the one that is in Marseille. And then, boom, we're in Marseille on the DriX number 6. And we've got our lines that are ready for our survey. We've just done the sound velocity probing using our winch that is installed on the DriX. And so now we're ready to actually launch the survey lines. So more or less the same process that we do with the hovering. Then this time I click on the lines that are displayed. Then right click, select the line that I want, pass following mode. I get access to a menu where I can define the speed that I want to perform my survey at. I'll define a survey mode because I want all the turns and everything computed with DriX. Therefore, I have my theoretical lines from my survey navigation software that I transferred onto the DriX, and is taking care of the rest, basically. I put a length in, length out, which has some distance that I want to add so that DriX is able to be well aligned with the theoretical line. And I can launch it onto its survey. Okay, so you can see the same green route. And now DriX is ready to start its survey. So we've got our auto recording that it's on for our survey data, and we've got the anti-collision that is on. So we're ready to leave him to its mission.
Okay, and I see on the screen here that it says there's the remaining time of that survey plan, which is 18 minutes and 22 seconds, and counting down as we go.
Exactly.
So that's up and running. We can leave it to itself. It's going to perform the survey route and
the anti-collision in case there is something on the route.
And take care of any obstacles on the way. So just a quick note on the obstacle avoidance. What's the...
Well, the anti-collision is a combination of several sensors that we integrated in DriX. First one is the AIS receiver. So we are receiving the positions, the course over ground, the speed of the other vessel that are using the AIS. And then we've got three other components. We've got the infrared camera, we've got the LiDAR, and we've got the radar. The infrared camera will look in the direction where the DriX is going and will be plotting even small objects like buoys. The LiDAR will do the same, but all around DriX with a range of about 100 to 150 meters. And finally, the radar will give us a bigger picture of the environment around DriX with a range of about 1,000 meters, and will be efficient to detect vessels that are moving fast, for example.
Sure, and then the collision avoidance algorithms are basically amalgamating all that sensor data and resolving any issues.
Exactly, combining everything together, and we will be able to see afterwards. You can see already on the screen you've got a green circle on the right side of the DriX, which is an IAS plot, so there's a vessel there. And when it's going to be all the other sensors, it's going to be a blue circle, so we'll be able to see if there's vessel on the way.
So we're going to leave this DriX getting on with its work, and let's get back to put the other one to work.
Okay.
Back in La Ciotat.
So same procedure. I just click on DriX number 3, and I'm back here in the middle of the Bay of La Ciotat. So DriX is still inside its circle. We can see from the plot that it moved, but it's actually still inside. So I'm just gonna stop this mission because for it this is a mission staying within this circle, and I'm gonna launch the survey lines just like I did with the previous DriX. Same procedure. You can create your theoretical lines within your survey navigation software and then just download that into the DriX HMI to have them displayed on the main DriX software. So if I click on the main line, right-clicking, line, select path following mode, boom, I have the trajectory just like we had on the other DriX. I use again the survey mode. I'm going to put maybe 50 meters and 50 meters, so you can see that it's adding some distance extra. 8 knots is fine for us. We can do I would say a fast survey. And same way, I just have to launch it on its mission. As soon as I press the start button, you can see again the same green trajectory. And like you mentioned, remaining time, this is really accurate, and it helps really surveyors when they have to plan several surveys. With this method, they know exactly how much time it's going to take.
Very useful.
Exactly.
Given our 30-minute window for this small demonstration.
Exactly. You can switch from one to the other. If I increase the speed, like I'll do just to check, 10 knots is recomputing the remaining time straight away. So it's really efficient and really accurate. And you can see that it's about to start its line, and it's going to start with its survey in a minute. Same procedure, auto recording and anti-collision on. So basically,
we can leave it to it.
Exactly.
To its
can
business
zoom out
and zoom back to the next to the other one and see how they're getting on over there.
Exactly. So if we are getting back to our DriX in Marseille, started its second line. We are monitoring, as an operator, we are able to monitor the telemetry data for both of the DriX and also the forward-looking camera of both of the DriX that allows us to actually see how it is on the field and monitor all the parameters for DriX. But as a surveyor, obviously, we'll focus on the survey side.
Yeah.
So DriX that is in Marseille is actually combining two different sensors. We've got a multi-beam system, which is a Kongsberg 2040C, and we've got a sub-bottom profiler, which is an RX Blue Echoes 3.5K. And both systems are running at the same time within the gondola that is 2 meters below the surface. We also have the inertial navigation system from RX Blue, the fins, that is in the gondola. And we've obviously got our GNSS in the mast that is providing the position. So DriX number 6 that is in Marseille is running with the survey navigation software Quincy. But just like any other surveyor and any other conventional survey vessel, I can actually quite easily access to all of the data that I'm interested in. So I've got my survey map with my survey data. So I can switch on to looking at the bathymetry, for example. So if I go on there, so I have access to quite a lot of interesting data. I'll switch from the standard deviation to the bathymetry to have a look. Okay, so I can see my bathymetric data. We've configured the 3D display to have a look at the full swath of the bathymetry on DriX. And we've got our sub-bottom data that we are recording at the same time using Delph acquisition software. So we've got our complete setup, and just like any other conventional vessel, we're just following and making our QC of the data in normal conditions, I would say.
And so in this particular demonstration, we're working with 4G communications channel, which is providing sufficient bandwidth for the control and also the QC of this data.
Yeah. We've got several ways of communication. Obviously, over the horizon, we've got the 4G. We are quite close to the shore. We've got a SATCOM high bandwidth. We've got a SATCOM low bandwidth. So basically, we always have a backup to have redundancy and to be able to switch from one to the other. We've got also simple Wi-Fi connection or a MBR connection, which in the case are you working with a mother vessel and you're doing combined survey together. Everything is already installed in the mast, so you can actually configure it the way you want, which gives quite some flexibility.
Yeah. Okay. So this survey is going to go on for another 13 minutes. We're not going to stay and watch it.
Yeah.
Should we call a halt to this and send it on its way home, and then we'll get back to looking at how the other boat's getting on. So show us how we can direct things from here. Yeah,
it's same, quite easy actually. Same way we launched it, we can stop it using the stop mission button. So if I click on this one, you'll see that straight away we don't have this trajectory calculated, and DriX is starting to slow down. Basically, it's just waiting for another mission. So we're just going to draw a route to go back to La Ciotat. That's where it's going to be picked up by our support team there. If I go to the edition menu, just can simply draw a line that goes from where the DriX is all around and then back in the Bay of La Ciotat. Okay, then I just have to right click. I'll zoom on where my DriX is, and I can just select path following mode. Straight away you've got the trajectory that is calculated. Can remove the survey mode because we're not doing survey anymore, and I can increase the speed a little bit because obviously you want it to be quickly back in La Ciotat. Same thing, interesting. We know that it's going to take 1 hour and 30 minutes to go back to La Ciotat. So as soon as I launch the mission, basically I can call the support team and say, okay, in about 1.5 hours, you will be able to see that DriX is getting back to the Bay of La Ciotat.
Perfect. Okay, so we can leave that to come home on its own, and then we can maybe just pop back to the
other
mission
one?
in La Ciotat and just see how that boat's getting on.
So just clicking on this one, we get back to the DriX on its mission. I'm gonna increase the speed a little bit.
Yeah, let's see how fast it can go and
exactly.
still get good data.
Yeah. So we're currently at 8 knots, as you can see on the Koenig data. I'll increase that to 12 knots to see how it's behaving. In the middle of the turn, so you can see that it's still keeping trajectory that is straight on the theoretical line. So the line keeping is excellent, and same as we did with the other DriX, we can switch on to the survey navigation software. So on this one, we have installed the Ava Navipack, so it's different from Quincy, but it gives you basically the same overview of all of the survey data. So if I go onto the software, basically you've got the same 3D view with the DriX running its line and the bathymetry as it's being recorded. I can also switch on to I don't know, sometimes like we like to see the standard deviation to check that everything is going well. So if I go into here, instead of depth, for example, I can show the standard deviation. Okay, and then we've got all of our 3D beams. We've got another access to all of the survey parameters that are coming in. So the GNSS positions, the INS data, everything put back together in our navigation software. So once again, same as for Quincy, we've got the full access to all of the bathymetric results.
So essentially, the survey operation, survey QC, is really just the same as if you were on board a normal conventional survey vessel, but remotely operated, as we see, either with a range of different sensors, different very flexible software options, and so on. Okay, so Olivier, let's call a halt to the mission here now, and let's have a look at the obstacle avoidance features that I know you wanted to show us.
Okay, so I'm going to stop the mission, just clicking on the stop button, and I'm going to move the DriX. So to do so, I'm going to just right-click, go to mode, maybe here, go to mode, and then I just launch the DriX. Same vector, then it's going to head back to port actually, and on the way it's going to...
Can slow down a little bit from 11 knots.
Yeah, probably a little bit too close to the shore. And then at some point we're going to plot our vessel on the way, and we'll see how the DriX managed to avoid it.
So to be clear here, this is a scenario that we are laying on for ourselves. We're not going to frighten any other users on the water. This is our boat, which is going to intervene in the DriX mission, essentially.
Yeah, exactly. So it started its line, so it's gonna. That's why I'm gonna increase a little bit the speed. 12 knots is still okay for the DriX. And as soon as he plot something on the screen, like we said, like the two blue circles. There's actually one that is blue and green. That's because we've got the AIS and the plot from the radar. As soon as is going to see an object or a vessel on its line, it's going to integrate the positions from the radar, and then it's going to avoid it. So actually we can see it on the screen that our vessel is going on the way of DriX. We can see this line here, which is the computed vector from DriX, taking into account the speed and the evolution of the position. And you can see that the green vector here is for now still on the line that we drew. So that's the theoretical line. And as soon as he will see that it's too close, he's gonna move this green route away from the actual route. Boom.
Okay.
You see?
So there we go. It's analysed that there's a potential collision and made an immediate alteration.
So I think we are about 250 meters from so still at 12 knots, so it's quite efficient.
Sure.
And as soon as the vessel will leave and he sees that it's no longer on the way, you can see that the green vector is already getting back to the line that was supposed to be taken, and then he's going to follow until he reaches the end of the line.
Well, that's a great little demonstration, and I think, so then it'll just come back onto line and carry on.
Yeah.
And I think, so then you wanted to show us some other features of the software and the control, the aspects of the control system.
Another feature that is interesting, you can see that we've got our what we call our mother vessel that is now displayed on the screen. This is a small boat symbol. We like to use this feature because sometimes when we have to go out with DriX, we've got quite long transit to do, and we don't want to have someone just looking all the time at DriX and monitoring the route and the safety of the route.
So it's broadcasting its identity essentially as a DriX mother vessel.
Exactly, we are receiving GNSS position from the mother vessel. It's a simple GNSS antenna, and that allows you to use what we call the follow me mode. The follow me mode is the ability of DriX to follow the mother vessel, even if it's moving, depending on the speed. If I right click on the symbol of our mother vessel, we can see that there's also the target on it. And I use the select follow me mode. I have access to this menu here, which I can actually set a few parameters. So I've got the maximum speed that I want the DriX to reach. Obviously, if the mother vessel is not going very fast, the DriX will not go very fast. It will follow it. I've got a safety distance, which is minimum distance to the vessel, the rear distance, the distance that I would like it to keep, and then a few parameters. I can use the exact follow me mode, which actually, if I launch it, will make the DriX follow exactly the path of the vessel. So even if the mother vessel is moving like this, DriX will follow exactly the same trajectory. And I can use another option, which is adding a side offset, whether on port side or on starboard side, from 50 to 500 meters. I can have the DriX, running just beyond the vessel, but on the side, and that way it will not follow exactly, obviously, the GNSS path. But that's also another option. So if, for example, I unclick this one, you can see DriX is straight going on starboard side because there is a side offset of 50 meters on starboard side. It's also an interesting feature if you have to, once again, conduct long transit between several survey areas, for example. Okay,
so this feature here we're going to use to allow the DriX in La Ciotat to be brought home to a safe end of the day. And presumably the same features you can use to allow the DriX to come into the deployment system, the DDS from a
exactly. It's working
scenario, the same functionality.
It's working exactly like that, and that's what we do most of the time when we have to recover DriX. Then a pilot will take manual control until we reach a port, and then they will recover it.
Yeah. Okay. Well, I think that's excellent, Olivier. I don't know if there's anything else that we want to show in the menus, or if
we can go quickly through the menus. Basically, we've got access to quite a lot of functions. So the DriX deployment system that you talked about, we are interacting as well with the DriX deployment system when it is when it is deployed on the project.
Yeah.
So opening the arms that will allow DriX to come in and closing them. This is done also using the same interface.
Okay.
We are able to tune the obstacle avoidance parameters depending on the area you're working on different situations. DriX configuration, which allows you to get access to a lot of parameters.
Yeah.
That's Wi-Fi, that's the connection type, that's the lever arm in your DriX, for example. The telemetry is what we've seen already.
Yeah.
So basically all of the parameters. The kill. So we are able to, from the control center, to bring the kill up and down. Obviously, there's safety precaution.
Safety limits on it.
Obviously.
Yeah.
We won't be allowed to bring the kill up if the vessel is moving, obviously. So it has to be stopped. Mm-hmm. And most of the time, the DriX pilot from the remote control will directly bring the kill up and down. The SVP winch that we talked about when we did the cast for both surveys. Mm-hmm. If we have a quick look at it. So we can obviously pour it on and then put a depth target, mm-hmm. and then the winch will automatically just leave the sound velocity probe to go down. Yeah. And we've got 500 meters of line on the winch, and then we bring it up, and it will automatically stop when it's reaching what we call its docking station.
Okay.
And the virtual remote control, we are able to synthesize virtual remote control directly from the software, which will allow to actually drive the DriX if you want. And the coding data that you've seen already, which is the basics information from DriX. So
that's a very quick snapshot of the software for people to get a feel for it. Very rich environment. I think that's what we've got time for. I can see the sun going down in the Mediterranean there. It looks wonderful, and DriX, the DriXs are on their way home.
Exactly.
So I think that's all we've got time for. But thank you very much, Olivier, for your hard work in putting this demonstration together. Hopefully, we've whetted people's appetites to learn more about DriX and other XBlue products. So thank you very much for joining us, and if you've got any questions, don't hesitate to contact XBlue after this broadcast. Thank you.
Thank you.